Okay, great. Well, I'd say without further ado, let's jump in. Let's do this. Hi, everybody. My name's Hannah. I'm the events manager at nofamass. You are attending Spent Mushroom Substrate as Compost Inoculant for Vegetable Farming with Rubén Parrilla and Elizabeth Almeida. And before we get in, I have a few details for us to review. This is our land acknowledgement that the conference is being presented on the land husband. Excuse me, I have a noisy person in the background. This land has been stewarded by Indigenous people since before the European colonization. And as we work to heal the destruction caused by colonization, we appreciate your support, solidarity, and continued learning. If you know whose land you're calling from, feel free to drop it in the chat. We'd love to see. And if you don't, check out the nativeland.ca. I'll go ahead and put that in the chat for you so you can see whose land you're calling from. So as you may know already, Buen Vivir is our theme for this conference. I highly recommend that you join us for our caucus groups on Saturday for lunchtime. There will be a BIPOC caucus, and I will be facilitating the White Ally caucus. We'll be jumping into the themes of Buen Vivir and how we can be great allies and be a part of the solution instead of perpetuating things that we don't really want to perpetuate anymore. So hope to see you there. And what you can do other than come to the caucus groups is center racial equity in your own community, a couple of different ways, like protecting the rights of food and farm workers, supporting legislation to advance the work towards reparations, supporting BIPOC-led organizations. And these are some in our area. We'd love for you to check them out. If there are any other organizations that you'd like to share, feel free to drop those in the chat as well. And a big thank you to our partner level sponsors, Stonyfield Organic, as well as a number of our other sponsors who make the conference possible. We encourage you to purchase from them, and when you do, let them know that you appreciate their support of nofamass. And then some more of our sponsors, which in this next slide, super relevant to this conversation, is our soil health table. If you're coming to the conference in person on Saturday in Worcester, there will be nofamass staff there if you bring a small soil sample from home who can offer some technical assistance, stick it under a microscope. It'll be a lot of fun. So hopefully this conversation will inspire you even more to do that if you weren't already thinking about nerding out on your soil sample already. And then of course our auction, we've got really, really great items to bid on in our online auction. So you can either take out your smartphone or wait for me to drop this link in the chat. Check out the great stuff that folks are providing. All the proceeds will go to supporting our nofamass's offerings throughout the year. And with that, I will be turning it over to our presenters. So first, we will be hearing from Elizabeth Almeida. She's the owner of Fat Moon Mushrooms. She started farming mushrooms after moving on from a small scale veggie CSA. Was growing mushrooms in her basement and then her yard, and now grows over 1,000 pounds a week in a mill building in Massachusetts. And she also is a part of the nonprofit Flowers to Empower, empowering girls ages 12 through 18 with entrepreneurship, leadership, and philanthropy. And we are so happy to have you, Elizabeth. And then after we hear from Elizabeth, we'll be hearing from Rubén, who is our Soil Tech Program Director here at nofamass. So yeah, so happy to be here. Go ahead, Elizabeth, it is yours.
Great. Thank you, Hannah. Good evening, everyone. So good to see you. It's really a pleasure and an honor to be here this evening to talk about mushrooms, talk about compost, and especially to share the stage or share the screen with Rubén. I learn something every time I talk with Rubén, And so I will go through my part of the presentation, but I'm super excited to hear about what Rubén has been finding in our compost lately. So I have some slides prepared, and I will share those and go through them. Feel free to pop comments in the chat, and if I see them and they're relevant, I'll answer them, or we can answer them towards the end. So Rubén and I both have some slides and material prepared, but we're going to leave plenty of time for discussion and questions as well. So I thought we could start. I just wanted to introduce my business and a little bit about growing mushrooms. And oops, I was trying to change my screen layout there a little bit so I can see all of your faces and my slides at the same time. So if you want to capture this QR code, it goes to our website where I have lots of resources about mushrooms. I just like to put this right up front in case you want to geek out about mushrooms all night long. There are plenty of websites and links in there, and we do sell grow kits, so I like to put a little coupon code up there as well. Newsletter, social media, all of that is available on our website. So I wanted to start here with a little bit about Fat Moon. You can see in the background of my pictures lots of mushrooms that we grow. We grow about 10 varieties. We are certified organic. We focus on the fruiting stage, the fruiting and distribution of the mushrooms. Here's a picture, a few pictures inside our facility. On the right, you can see inside one of the grow rooms. We have 4 grow rooms that are each about 8 feet by 24 feet. And we can adjust the temperature and the humidity. That's why we have so many grow rooms, so we can tailor the growing conditions depending on what mushrooms we're growing. And then on the left there, you see part of my crew. I have about 10 employees. The mushrooms need to be tended every day. They need to be harvested daily. So we have great crew, 1 full-time and about 10 part-time folks, because we have at least 2 people there every morning to at least do the harvest, and then whatever maintenance needs to be done on the mushrooms. I have some beautiful pictures here of some of the things we grow. So all the mushrooms we grow on our farm grow on sawdust in the light, or cellulose in the light. So someone was mentioning Kennett Square, Pennsylvania, where most of the mushrooms in the country are grown, and like something like 90% of the mushrooms consumed in the US are the white button mushrooms, Bisporus agaricus. Those are grown on composted animal manure in the dark. So what we're discussing with spent mushroom substrate today, it's a different substrate. We're starting with cellulose, and so you'll see I have some compost analysis, a lot of carbon. If you're getting the spent mushroom substrate from the farms in Pennsylvania, it will be very different than what we're working with. I point that out also because the research that has been done on the spent mushroom substrate, you can find a lot from Pennsylvania State University. Penn State does most of the mushroom research in the country. So if you're looking, research that's been done at the public institutions, a lot of it comes from Penn State since they have such a large mushroom industry. But just know that as you're looking at any research about their mushroom compost, it's probably very different than what we're starting with here. So many of the mushrooms we do grow in the wild here in New England, which I find exciting that we're working with native species and we're learning how to cultivate them. So the shiitake is one that does not grow in the wild here, but is amenable to our climate. And then lion's mane, perhaps you found lion's mane in the wild before. We also grow combs tooth, which is the same genus, different species of lion's mane. The chestnut mushrooms on the right, those are Pholiota adiposa. That does grow in the wild here, but there are some poisonous lookalikes and some of the Pholiota mushrooms that you don't want to eat. So I would not recommend ever foraging for Pholiota mushrooms in New England. On the left here on this screen, you'll see our blue oyster mushrooms. We will be talking more about the oyster mushrooms. They're pretty exciting in this compost research. And they do grow in the wild here in New England. And then we have black pearl mushrooms, which are crossed between king trumpets and the oysters. And then these beautiful yellow oysters over on the right. We have a few other varieties that we grow in addition to these. And then our mushrooms are sold a few different ways. Here we have a picture of one of our farm stands. This is Land's Sake in Weston. About a third of our mushrooms go out to independent retailers, boutique retailers like farm stands and independent grocery stores. And then about a third of them go out to CSA. So we partner with a lot of farms to offer a mushroom CSA add-on to their vegetable share. And that's been extremely popular and a great market for our mushrooms. And then the other third goes to restaurants. So we have quite a few wholesale accounts, and we work with Costa, a big distributor, to take our mushrooms further than what we can do through self-distribution. And I would just say one other piece that's exciting about our farm. I don't know if some of you have heard this statistic. Of course, the number of farmers in the United States is shrinking, and Middlesex County, Massachusetts is one of the few counties in the whole country that's seen an increase in the number of farms in the past decade. And a big part of the increase has come from female farmers. So that's part of why I love this picture. It's great to be a part of a growing community of farmers here in New England and in Massachusetts. All right, so now we get to the juicy pictures and why we're here today to talk about the compost. So Rubén and I met a few years ago when Rubén was a previous job. I forget even how it started, but I took some compost over. They came to pick up some compost. Rubén started looking at it and said, "Wow, do you know what you have here?" And I didn't. I just knew that it was grew fantastic tomatoes, but I didn't really know what was in it. So we started, and at that point I was just passively composting my waste. So I was a smaller scale. We were doing maybe 200 to 300 pounds a week. I could still manually handle all my waste. So I was loading in my pickup truck from the mill building where we're working, hauling it home, paying my kids to unload the pickup truck, much to their chagrin, and then just let it passively compost on the edge of the woods for a year or two, and ended up with a gorgeous compost as a result. So as we go through, I think it's helpful to understand the life cycle of the mushroom. And what exactly it is we're composting. So the mushroom life cycle can start up here around between spore release and inoculation. So generally with mushrooms, it takes 2 spores to start a new organism, but they're not male and female spores. So any 2 spores can connect, inoculate, and then you get this mycelium will start growing. If you've ever kicked a piece of bark off a tree in the woods and seen that white webbing, that's mycelium. And the mycelium will expand. It's looking for a food source. There's some intelligence there as it spreads out. It's looking for a food source and then grows towards the food. The mycelium, when the conditions are right, it'll form a hyphal knot. That's a concentration of mycelium. That mycelium then, or the hyphal knot, starts to grow into primordia. Primordia are just tiny baby mushrooms, or we call them pins. There's a stage of fruit body selection. So an oyster mushroom, when we grow them, they might produce thousands of pins, and then maybe 100 of them will mature. So after fruit body selection, then the mushrooms mature, and from step 6 to step 7, that might be 3 days. So mushrooms grow very quickly. They double in size overnight. And the purpose of the mushroom is reproduction. It's the reproductive body. So that mushroom will then release spores and start the process over. So we've been, I did a little testing on our substrate because I've been trying to figure out how to scale up my compost. And so I was trying to figure out what I'm starting with. So the number that the reason I did this analysis of our spent mushroom substrate was to get our carbon to nitrogen ratio to see what we wanted to add for carbon. So you can see that, and it was also very curious because we start with a lot of carbon with sawdust, but trying to understand what's happened as that mycelium has grown and started to decompose the that sawdust, is the nitrogen being released. So anyway, we're starting with a 41, the ratio of 41, and then after it decomposed, just sitting in my yard passively, we were down to 18. So that was useful information to start thinking about how much nitrogen do we need to bring in. And we actually, what we had figured out was that we didn't need to bring in as much nitrogen as we thought, because the original assumption was, well, we're working with sawdust, so it's all carbon. But no, it's the mushroom, the mycelium, and the fungus has already begun that process. So we could bring in less nitrogen. We're actually experimenting with do we need to bring in any at all? Like what happens if we don't bring any in? Or what kind of nitrogen do we want to bring in? So those are all variables that Rubén and I are still discussing. So I just wanted to mention the reason I'm interested in this is because we're producing about 6 yards of waste a week. And right now I have a few farm partners that pick it up and add it to their compost pile because they see it as adding volume and it's a valuable amendment. It's bringing in more of the carbon, which a lot of our local farms need this time of the year in their compost piles. For our business, this is vertical integration. We could start making a product and selling a product from our waste, which is valuable for the business. And then, I like the idea of creating another valuable resource for New England farmers. I think that's part of why we are all excited about the local food system, looking for ways that one person's waste can be an input for someone else. That's one of the problems with any type of concentrated industrialized agriculture is that concentration of waste. It's got to go somewhere. If our waste in agriculture is distributed, then it can become a valuable input instead of being a liability. And then this is the last slide I have here, but I have a series of pictures to share. So we've tried a few different things so far. First, just the passive composting on the edge of the woods, which has given us a rich diversity of microbes that Rubén has found. And we'll talk about also the earthworms moved in. Fortunately, no Asian jumping worms that I've seen yet. All good little red wigglers doing their job. We've set up Johnson-Su bioreactors, which I can flip over to my folder of photos and show you that. And right now we have 2 vermiculture bins, continuous feed vermiculture bins set up indoors that we're feeding. And the worms are very happy in those bins to the point that this week we're having a conversation about, do we have too many worms in here? Do we need to start dividing, selling? Like how many worms can we tolerate in one bin before we need to get serious about dividing or selling? So I wanted to, if this time, I think I still have time here, I'll go over and I want to share with you some of the photos.
You have plenty of time. You have like 10 minutes.
Okay. Great. So I don't know if folks are familiar with the Johnson-Su bioreactors. This is a model that Rubén showed us. So one of the challenges for me for composting is that our business is in a mill building and there is land, but I don't have a piece of equipment there. And so I've been trying to figure out what we're going to do so I can decide what scale I need, how big of a tractor do I need basically to move all this compost. So we were trying these Johnson-Su bioreactors because they're static and don't require a lot of turning. We built 5 of them last year as a pilot. They are costing us too much in labor to construct and fill, but we are quite pleased with the results. So I included these pictures. So you start by cutting holes in a pallet, and then you put in, this is like concrete stuff you use when you pour concrete. So very high, very strong wire mesh. And then you put these PVC pipes in, I think it's 5 or 6 per bin. And then you start filling it, which is a really dirty, messy job because you're supposed to completely hydrate the material. So we had bins with substrate and we were soaking it, trying to soak all of it for a half hour. And we were layering in alfalfa and bunny poo to add some nitrogen to it. So not an exact science here, but getting the job done. So this is what it was looking like afterwards. Let me see if I can. Sorry, I'm just trying to go back to my photo screen. There are a couple pictures I wanted to show you. What is really cool is with the Johnson-Su method, you have those PVC pipes and then you pull the pipes out after a day or two and the compost has settled and the holes stay in. I'm looking for a good picture with the holes. The holes remain and they act like chimneys so that as the pile heats up, you're getting air circulation and air moving up, and you water it regularly. Although I have to say I have not watered our Johnson-Su's this year at all. Granted, there's been a lot of rain, but still the instructions say to water daily. However, this method was developed in Arizona where the air is much, much drier. So, you know, we all know that nothing is drying out in New England these days. But I didn't water all winter, all spring, and it was still really wet. So the water retention, you know, the moisture retention of this compost was outstanding, I thought. But you can see here, we pulled the pipes out. I actually put short 6-inch pieces back in because I was adding some earthworms at the top and I didn't want everything just falling through the holes. So I put just little 6-inch pieces of pipe back in at the top. And then I love this picture of it. This is the top of one of the bioreactors, and you can see the fungus coming up here, some different types of cup fungus. So it's been really interesting to watch what has moved in. And that may have come in some of the grass clippings we put in. I moved earthworms from my house over to the site. So I'm not, you know, or it could have been airborne, the spores of something else moving in. So that is everything I had prepared for pictures. Happy to answer questions about growing mushrooms or about the substrate and what I'm putting in, what I've put into these bioreactors or how we did it. Happy to chat about anything on my end before Rubén starts talking about the specifics with the compost.
I actually do have a question.
Yeah.
I've always wondered this because I know that the mushroom is the fruiting body. At what point it releases spore, and if you can harvest it too early? I know it's not really like central to our talk, but while I have you.
Sure. You know what? Actually, I think I have some pictures in my mushroom. Let me show you pictures of my compost pile, because then I had a really good juicy one here earlier when I was you can eat mushrooms when they're immature and they're small. That's all fine. Here's a good one, I think. So you can see here like mushrooms at different stages of development, some little ones in the back, some bigger ones. They drop their spores when they're fully open or fully mature. And we try to harvest them before they're fully mature, because once they drop their spores, the process of senescence begins. They've fulfilled their purpose in life and they begin to decay. For eating purposes, it's better to harvest them a day too early and harvest them slightly immature than waiting until they're fully, you know, reach their maximum development, because once they've dropped their spores, it's actually, they're dying, they're done with. And a few of the mushrooms, like chestnut mushrooms, I'm always on my crew to pick them a day early because they have no shelf life if we pick them a day too late. And I find even the shiitakes, if we pick them a day too early, their shelf life might be 2 weeks. If we pick them a day too late, the shelf life might be 3 days.
Wow. Glad I asked. Anyone else have questions for Elizabeth while we're here?
I had one question.
Sure.
This is Nagisa's husband. So when you're looking at the carbon and nitrogen ratio, you know, do you have like a general target you're shooting for?
I forget what I was going for there, Rubén. I remember.
Yeah, I mean,
I'll let you answer that, Rubén.
the sweet spot for any composting is about 35. 25 to 30 actually would be the sweet spot that you're targeting for when you're developing a recipe for composting.
Okay, I'm an oceanographer, so the ocean average is 16. So I was just curious. So awesome, thank you.
Well, interesting enough, actually, soils have an average about 18 or so, 16 to 18 as well. So very similar, which is interesting too, right?
Yeah, the Earth system science. Thank you.
Great. Well, let's go ahead and pass it to Rubén then. Thank you so much, Elizabeth.
You're welcome.
If anyone else has questions for Elizabeth, feel free to drop them in the chat.
Yeah, for some reason, I actually thought I forgot that I was presenting. I was like, oh, continue talking.
Oh, I can keep talking about mushrooms, but I will go off the topic of compost. So I'm trying to stay on topic here.
No, thank you. I appreciate that. All right, so
Unless, Ruben, while you're getting ready there, I'll just share that in the vein of the compost work, we have established a relationship with Clark University and Dr. David Hibbets, a mycologist there, which has been very fun to go down to his lab. He loves that I'm doing something in industry out in the world and using mycology to feed people. I'm totally fascinated by the science that they're doing in their lab. So we have a great relationship. And Ruben, should I go ahead and tell them what I learned about the nematodes, or do you want to save that for later?
oh, please go for it.
All right. So he has a scientist researching oyster mushrooms and nematodes, because Ruben will tell you that what first caught his attention about my compost was the presence of nematodes and the quantity of nematodes in a sample. And when I mentioned this to Dr. Hibbets, he said, well, of course, you didn't know you're a nematode farmer. And that's when I learned that oyster mushrooms play happy host to nematodes, and they have a lovely relationship. And the oyster mushrooms will host the nematodes until they run out of nitrogen. And then the oyster mushrooms emit a toxin that will kill the nematodes so they can eat them, which I love. And they're researching at Clark, like, what is that trigger? And what's that? How does that mechanism work? So I'm staying in touch with Dr. Hibbets. I heard he just got 2 new grad students who are continuing this research. So I'm excited to learn, what's next. And I think there's also, to me, a huge question of what kind of nematodes, because not all nematodes are created equal for organic farming. There's certainly plenty that we like to have in the soil, and they are beneficial because they make the nutrients bioavailable. So they're really beneficial, but we all know about nematodes that are also can cause crop failure and other problems in some crops. So that's part of the science part to figure out, if we can cultivate the right nematodes in our compost.
Yeah, and to add to that, Liz, people that are going to anybody thinking of doing these processes later on after we go through this whole project, don't fret about that, because the nematodes that we find in composting are not going to be detrimental nematodes, for the fact that the more detrimental nematodes would be the root feeding nematodes, which you wouldn't find in a compost anyways, because there's no plants growing in there, right? So for this practice that we're going to be talking about today, we shouldn't worry about bad nematodes, right?
You have a question in the chat here, Elizabeth. Oh, you got it. Okay.
Yeah.
All right, so let's go ahead and try to start this. You guys see my screen?
Yep, you're good.
Let me just presenter mode. All right, great. Useless intro slide here. Let's just skip that. All right, so what we're going to be doing here today is I just listed a few of the key points that I'm going to try to convey today. The why of what motivated this process to begin with. What is it that keeps us up at night when we decide to do projects. The how, what type of tools. We'll discuss a few of the define a few of the tools that we're using. And then who can partake in this process, right? Is this for a composter? Is it for the backyard person? So we'll go through all these, and hopefully we can get some input from you as well. We'll go through these rather quickly. Actually, we want to leave enough time to for our people to have, if you have any questions, we want to leave enough time for that. Questions and discussions too. It could be that it could be a more dynamic way of doing this as well. All right. So the why, kind of wrote something down. I do want to write, I spent the time writing it, so I do want to kind of read it. So the work that we're about to dive into is motivated by a few factors. Firstly, we recognize that the importance of minimizing waste streams in our agricultural systems. And as mushroom farmers generate significant quantities of spent substrate during their cultivation process, finding innovative ways to utilize this abundant resource becomes crucial to reducing waste and promoting environmental stewardship. In addition, to waste reduction, we are driven by the desire to improve compost quality. Composting plays a vital role in transforming organic materials into nutrient-rich amendments for our soils. By incorporated spent substrate as a fungal inoculant into composting systems, we aim to enhance the decomposition process, enrich the nutrient content, and optimize the overall quality of compost. We are deeply committed to enhancing soil health, recognizing its pivotal role in the success of our agricultural endeavors. By utilizing spent substrate, we seek to promote the growth and diversity of beneficial soil microorganisms, enhance soil structure, and increase nutrient availability, all of which contribute to fostering healthier and more resilient soils. Ultimately, our efforts are driven by profound understanding of benefits that healthy soils bring to plant growth and overall agricultural productivity. By harnessing the potential of spent substrate as compost inoculant, we aim to provide plants with thriving environment enriched with essential nutrients, beneficial microbes, and optimal soil conditions. This in turn can lead to improved crop yields, enhanced plant health, and increased resilience to environmental stressors. In conclusion, in today's workshop, it's a testament to our commitment to minimize waste, improving compost quality, enhancing soil health, and maximizing the benefits for plant growth. We hope that through our collective exploration and shared knowledge, we can pave the way for a more sustainable and regenerative future in vegetable farming. That was my monologue there. And now I can actually speak like a normal human being. All right, so oops. Yeah, boy, no. Go back. All right, so as I mentioned earlier, we're gonna be talking now about the how. And let's see here, what do we have here? So luckily enough, Liz already showed us some beautiful pictures of the spent substrate. But for those that don't know, SMS for short, is just basically leftover material from the mushroom process, from the mushroom growing process. In this, we can actually make a few notes of its abundance. Liz actually mentioned this earlier, how the mushroom farming is a thriving industry, and there's an abundance of this material that has so many benefits that we'll talk about in a little bit, and that farmers in the Northeast should actually be excited about this because there's an abundance of this material that we can actually utilize. Another line item here about the SMS, it's that it's nutrient rich, right? These, as Liz mentioned earlier, in this particular case, and when we're for the purpose of this talk, we're actually going to be speaking directly on sawdust spawn and sawdust-based material, such as the one that we're working on right now. As Liz mentioned earlier, there's other substrate that you can utilize for growing mushrooms, but in this case, we're talking about the sawdust spawn. So, when we talk about nutrient-rich materials, the substrate clearly contains nutrients that we all know that the mushroom mycelia actually hold and mine for as well. They are a tremendous amount of organic matter that's being added to this too. I don't know if you guys noticed, but in the laboratory reports that Liz mentioned showed up earlier, you can see that there was actually a good amount of organic matter. And organic matter is something that we always aim to increase in our soils, especially in agriculture, where organic matter is constantly being depleted. And then also a high carbon source. This is, like Liz mentioned, this is a substrate that has a great carbon source that many farmers can utilize in many different ways. Okay. So now comes the major tool that we actually have been utilizing for this project. And so one of the things that is crucial for evaluating microbial populations are the direct microscopy. There are many methods that we can actually utilize for evaluating microbial biomass. However, this is something that we actually have a few folks at NOFA trained in. We have, I'm happy to say, actually, we have in this state of Massachusetts, we actually have 2 certified techs from the Soil Food Web, which both work for nofamass. So big ups to nofamass for having the 2 soil techs that are certified, right? And then for the most part, you can actually see parts of the microscope here. If anybody needs any specifics as to what kind of microscope you should get if you're trying to evaluate soil food web, please send an email and I'll give you those specifics. However, for the most part, the majority of the work that we do it at a 400 total magnification. And nematodes or larger microorganisms such as microarthropods and water bears, things like that, those you can actually clearly see with objectives of 100 total magnification. So now that we have the tool and we know what substrate is, let's move on. So I'm pretty sure everybody has, or the majority of people actually now have seen this chart here. And the reason why I bring this chart or this graph is to talk about, we talked about this, the SMS as, what we're using. We now talked about the tool, but what are we evaluating with that tool, right? And so these are the players that we're looking for. Specifically, we are looking at trophic levels from the second trophic level through the 4th trophic level. So these will include bacteria, fungi, nematodes, microarthropods, and the different types of protozoa. Those would be the ones that we're actually looking at the microscope, counting. We count each individual and then produce a report. So once we actually have acquired that data, we go ahead and put out a nifty report. With the report, you're actually getting micrograms per gram of both fungi and bacteria. You can get a ratio of those as well. You can't really see this report very well, so this is just a blow up of the first section there that we have, just so you can get an idea of what a report would look like. So this is the work that we do in terms of evaluating the compost, and we'll go into each detail later on as in the how to. But this is actually the data that we are collecting when evaluating the inoculum or the compost post-inoculum. All right, so we now saw what, how, and the tools and who really of who we're looking at. So let's jump into some of this data, right? So as I mentioned earlier, when we first, so part of this process that motivated this project was looking at a lot of compost with the microscope. We were finding that most of the compost that we were evaluating always lacked fungal partners. And so part of this motivation said, okay, well, let's try to, the obvious thing was to let's get fungi to inoculate these compost piles. And so the obvious was, okay, well, yes, your fungal activity will increase if you actually put these, and mix this substrate into your compost. So that was one finding that was not a surprise to us when we were doing this. However, as we're going through the process, you know, what we started seeing was things like what Elizabeth mentioned about, you know, our nematodes. You know, the nematodes increase greatly, and we'll look at those as well. But also understanding too that fungi have, not only are they bringing all of these wonderful things that we just talked about, but they also have a consortium of other organisms that come along with them. We're talking about epiphytes that actually just grow along them. We're talking about endophytes that actually grow inside of these mushrooms. So yes, bacteria do grow inside of mushrooms, and they actually are a host of a ton of different bacteria. And each one of these fungi do have a different consortium of this. So so it was no surprise after learning these things that we saw differences in biomass based on just bringing fungal partners into the mix. So real quick here, as you can see, these graphs that I'm going to be showing you, I specifically chose 2 farms to showcase. And the reason why I chose these 2 farms is because we're using the same compost to start with. And so that actually was going to give us an understanding of, okay, well, if you use the same compost, are you going to get the same results if you are actually doing this inoculum at different places? So this is very important to understand, because obviously everybody, if you're going to try this process, you're not going to get the same results. You know, your microbiome in your own area will perhaps dictate how these, how your results go. But let's go ahead and real quick to clarify here on the graph of the below axis, the BC stands for background compost. 10 is 10% SMS inoculated into compost. 25 and 50 are also, you know, 25%, 50%. So 10% SMS, 90% compost, and so on. I hope that was clear. All right, so again, we are looking at the same compost, evaluated different times, and mixed in at different places. And right off the bat, you can actually notice, pay attention to the units here, because the unit on the right is actually skewing the bar graph. You can see that the bacteria from the compost was way greater, much greater in that farm than the other. However, even though these are the same compost, but they were brought to another area and evaluated then, right? And so when you look at the data on the left here, we are actually seeing increasing bacterial concentrations with increasing concentrations of SMS. Whereas in the one on the right, we're actually seeing the concentrations actually throughout the entire inoculums, the 10, 25, and 50, remain somewhat similar. And we can talk a little bit about that based on the next slide here. So as you can see here, there's a thing called predator-prey interactions, right? So wherever you actually have predators in a system, like any ecosystem, you can talk about the ocean where you actually have sharks. If you have these predators, or even let's say an orca, which is an apex predator, if you have these predators in the system, that means that your system, ecologically speaking, your system is actually rich and healthy because you have these. However, there's ebbs and flows and predator-prey interactions when it comes to these microbes as well. So when you actually have certain foods, you would actually naturally increase the predators in that system to feed those, and also control and put the system into balance. So where we actually have here is, when you look back at the previous slide, the samples on the right-hand side from that project, you can actually then correlate that to some of the organisms that were actually preying on them. And so when you look at the samples on the right, you can see that the protozoa were actually at greater numbers, meaning that there were more predators in that system to control the bacteria. And thus the bacteria actually were in a plateau, if you want to say it that way. So the predators were indeed actually bringing balance to the system, and that's what we're seeing in these data. And then finally, the last set of organisms here for the analytical results here are nematodes. As we spoke earlier, what was really surprising behind all of this were the amount of nematodes. The first time I actually put these under a slide, I thought that I was either going crazy or I was counting nematode, recounting the same nematode, or, like, did this nematode move from the slide to the other slide? To the point where I actually had to get some of my colleagues and also look at these and say, can you please confirm that I'm actually counting right? So this was a great surprise for us because this is something that is unfortunately not found in many soil systems. Some of the work that we actually did was to evaluate also the background soil of where this compost was going to end up. None of the soil that we tested had nematodes in them. And so this was very exciting because, the thought is, okay, well, we're going to be bringing a ton of nematodes into these systems. The one farm that I actually saw that we encountered nematodes, that farm actually is already using, they are a mushroom farmer. And so they are already using this substrate as a part of their composting system. They weren't using it the way we are. But something to also keep of note that, there is perhaps some evidence showing that even in the composting process, you can potentially be bringing them, even if they go through the thermophilic process, you can be including some of these microorganisms. So what is it that we actually learned from all these data so far that we have collected? When we look at the trends, we can actually see that there was an overall increase in biomass. So every single one, so no matter what concentration we started at, but every single point that we're looking at, whether those were bacteria, fungi, protozoa, nematodes, actually with the exception of bacteria, there was an overall microbial biomass that increased, right? With that, also comes greater diversity, right? So if we actually have higher numbers of these organisms, we are also bringing in greater diversity. This is something that Liz and I have talked about prior, about primary and secondary decomposers. And again, they all bring their consortium of their own microbiome to begin with. And so when you're actually including these, yes, you are bringing diversity just because these fungal partners do have, they are associated with other types of microbes. Again, soil or organic matter. We understand that there's going to be an increase in soil organic matter just from the decomposition of these microbes that are going to help with, increasing the organic matter. Greater nutrient cycling. And this is something that I encourage folks to actually try to go to the other talk on microbial predators. I can't remember what the title is, but I know it's happening in the next couple of days, where they can perhaps actually get into greater detail on what it means on this on this nutrient cycling. But very quickly, with these microbes, there's obviously going to be nutrient cycling because every microbe is going to consume another one, and that excretion will actually be made in nutrient in a plant available form. So essentially, it's what's referred to as a poop loop, right? So an animal eats another animal and poops out they poop, and then that poop is actually great nutrients for the plant. So again, some of these things are interrelated. So there's obviously going to be pathogen resistance if we actually have greater diversity or greater biodiversity. And so this is what we have concluded, but as we are going through this process, what we're finding is that there's a lot more than we actually understood to begin with. One thing that came to me the other day was, well, one thing that I haven't really been paying attention to or thought about was trichoderma. Trichoderma is it's a common I'm going to call it contaminant for the purposes of mushroom growing, but it's a common contaminant in mushroom cultivation. The substrate, this SMS, actually a lot of times you can actually see trichoderma growing on them, after they've been sitting outside for any amount of time, and so this is something that never occurred to me, but after thinking about it, I'm like, oh, wait a second, we are actually introducing trichoderma into these piles. So not only are we actually increasing this biodiversity, but we're also now increasing or adding a specific fungal partner that we all know actually has great benefits in the agriculture industry. Trichoderma is a lot of times sold to farmers as a biocontrol agent. And so this is actually something that is a byproduct of cultivating mushrooms, something that you do not have to purchase, because if you partner with some of these farmers that are growing mushrooms, or you're growing mushrooms yourself, this is something that you would actually have available. Another thing too that occurred to me was, we were often talking about the application of compost directly after a period of incubation onto soils. And so I don't know why I didn't think about this, but when we are doing compost teas and brews, a lot of times what we do is we determine the amount of compost that we use based on the microbial activity. Higher biomass means that you can use less and therefore have a great brew, because what you're doing is you're actually already starting with a good biomass to begin with that you're going to be spraying out. And so if we have noticed that these piles that are inoculated and are increasing this overall biomass, biodiversity, this means that they can actually make a great brew as well. And so that's another way to think about, what this mushroom substrate is doing to this finished compost. And before I go into the next section here, I wonder if anybody has any questions or anything that's burning that you want to talk about. No questions. Great. All right. So let's move on. All right. So, what did we do? Here's the a quick breakdown of how we did this, right? So the first thing is partner yourself with an awesome mushroom farmer that's as crazy as you are to actually do experiments like this. And once you have your spent mushroom substrate, what you're going to do is you're actually going to break this all apart. The reason why you want to break it apart is because you want to increase the points of inoculation. This is similar to people that are actually, if you've ever grown mushrooms, part of the process is to actually increase points of inoculation. And you do that as, and you sometimes break up substrate, especially if they're in bags and things like that, to increase surface area and points of inoculation. So you want to make sure that you break down your mushroom substrate as best as you can. Once you break it down, you're actually going to take finished compost. You want finished compost because you don't want this to heat up or go through a thermophilic process. that is going to drive your microbes away. What we're doing here is an inoculum. We're not composting. This is finished compost that has been settled. Once compost settles, your bottle of fatty acids will go down, and it won't reach that thermophilic phase either, which is not what we're looking for. So the ratios that we actually went for were 10, 25, and 50. We talked about these a little bit in the graphs. We noticed that 50% actually have the greater amount of microbial biomass when compared to the other ratios. One thing of caution here, now that I'm on that line item, if you recall that report from Liz, I don't know if people were able to notice the pH. So mushrooms are an incredible biofactory. They can create enzymes and different types of enzymes. One single species can actually, or one single individual can actually produce multiple enzymes at once to digest different foods at once. This goes to speak to the resilience of these mushrooms. And so when they're in a compost system, they're actually going to be excreting these enzymes. These enzymes are actually highly acidic. So one thing to know is, regardless of what ratio you're going to be using, pay attention to the pH, because that can be something that you want to be looking at. Many, different plants have different requirements, and so you should be paying attention to that pH. Understanding that the more substrate you add, the more of these enzymes are going to be in your pile, and therefore the pH will be lower. The next step of the process was thoroughly incorporated into the compost pile by volume. You can see in that picture there's a 5-gallon bucket. We did this volume to volume. It's the easiest way to do this, at least at this scale. And then we incubated these for about 2 weeks. 2 weeks was a minimum period of incubation. But I encourage people to actually use different types of incubation. We're restricted by this project because we have deadlines of this project. But when I encourage people that are going to be, playing around with this, try different things. Let it sit there for a year or 6 months, right? Try different variations. And then as you do this, monitor for moisture. When we first set out to do this, we were looking at different incubation temperatures and moisture. And so you want to make sure that that your conditions are conducive for growing out these mushrooms. And then lastly, once you have gone through the process, you just use the mushroom or the compost as you normally would. If you're making compost teas or extracts, you would do it the same way. If you're applying directly onto your soils, you would want to do that as well. And just for context here, the picture at the bottom here where I'm holding my mycelium mat, this was actually prior to starting this process. I was working at a worm farm where Liz was actually bringing, or we were getting substrate from Liz. And this was my first experimental pile. And once I saw this, which by the way, there was compost in that bucket, which you can't really distinguish what's compost and what's actually mycelia anymore. The mushroom just ran through the entire compost. Obviously, I had like the perfect conditions in the bucket indoors, I control everything. But once I saw this, I was like, okay, well, we have proof of concept here that this can work. And then on the other picture there, we have our furry friend there. We have Matt Feinstein from Global Village and my daughter, which I'll talk a little bit about that too on community building in a second. All right, so this is a call to action now for folks, right? The bottom line is that this process works. There's a few things that you might want to monitor, but this process is a great way to reduce the waste, increase your microbial biomass in your compost, and then reap all the benefits that happen from good compost. And so I wrote down a few line items here that we can just briefly discuss. I know we're almost on time here. But I wanted to frame this because I've been struggling with the word organic for a while. And I want to frame this this process as being something that putting your organic farming mindset hat on, meaning when you're farming in organic, forget the label, forget the certification, look at the ways that you can actually, when you're growing organically, you are in control. You have full autonomy. You are a researcher. You are a student. You don't have to conform to the box that you've been told to actually, you have to do it this way, otherwise it's wrong. And so this is, open up this experimentation, open up to, these, have an open mindset of, organic farming. So just wanted to put that out there. Another thing too is obviously connect with your food producers in your area. Who is growing mushrooms? Who is actually, who has waste? This is the organic mindset that I'm talking about, right? Who has a problem that you can actually be solving by having this organic mindset? And so this is a plug, I guess. It goes to the reach out to NOFA thing here. This is a shameless plug for NOFA, but, come to conferences, come to our ed events, networking and finding people around you that have similar mindsets can actually spark this interest and actually be a part of the solution to finding finding solutions to these problems. Again, experiment with the SMS too. We gave you some guidelines, but you don't have to follow these guidelines exactly. As I mentioned earlier, we had two same compost, two different results, just because they were done in different areas. Were those results different because of the volume that was used? Was it because, different folks actually mixed the compost together? Was the intention different from one to another? And that goes back to the community building part that I'm so grateful for being a part of this, because at every farm that I went to mix this material up, families got involved. I was at one point, there was some family members that came from Mexico that some young kids that they were told to go help Rubén over there. But it was nice because I was able to talk politics and just, shoot the shit with them, really. And another farm, as you saw, my daughter was there with me. She played with her little friend Micah from Gold Village, which was great. The youth at Tapley was an awesome way to actually get the youth involved with the project too. And so I encourage people to stay curious, and over all of this, please have fun while you're doing this, because if you're not having fun, you're not doing it the right way. So with that, I will leave it open for questions.
That was great, Rubén and Elizabeth. What happens when you put the SMS in the vermicompost bin?
The worms love it.
Yeah.
They absolutely love it. Yeah.
I do think it's like an aphrodisiac for the worms. I mean, just what I have seen in my outdoor compost pile and now in the vermiculture, the number of cocoons seems crazy. So I'm not sure what the trigger is or what's going on there, but the reproduction is certainly high with the worms.
And it sounds also, Rubén, it sounds like you've made some tea out of it.
I haven't made any tea yet, actually. But actually, I wonder if Global Village has.
Yeah,
that would be something to follow up with, because I know that they have a brewer there, and but I don't know if they were actually using this compost versus their own compost.
Great.
But yeah, we need to experiment with that.
Looks like Sister Anna and I had the same question. we're talking about adding this substrate directly to soil or garden bed. Can you elaborate on why we would want to mix it into compost, or if it's, you know, almost just as good to add it straight to the soil?
Yeah, you don't want to add it straight to the soil. The carbon to nitrogen ratio is too high. So you don't want to be doing that. You want to buffer it, basically. You want to buffer the SMS into compost, similar to how we do with other amendments, right? You know, there are a lot of amendments that we actually use a carbon source. Actually, the other way around, right? You use a carbon source to apply it before you apply it to soil. So you don't want to apply it directly to soil. However, I think there are some people experimenting with that. In New York, there was a group of people that reached out to us when they saw this on the SARE website. So that may be something that we can follow up with, you know, to see what they did. Again, this is what I talk about, having that organic mindset, right? There are no hard, fast rules here. You know, you have to experiment. Just because a laboratory told you, well, we found this at a lab, doesn't mean that it's not going to work in your system. And so we have to break away from these notions that, okay, well, this white paper said this, or this lab said this, or this land-grant university said this. You know, we have to do our own experimentation in our own context.
So I would add to that, add to Ruben's response. I did a few years ago try putting my tomato seedlings directly in some spent mushroom substrate, you know, broke it up, used it like potting soil. Miserable results, don't do that. And then the second thing is, other mushroom farmers I talked to have applied it directly, like in the fall, and then work it in or let it sit, you know, but give it time if you're going to apply it directly to your field. And Joan mentioned, you know, isn't Coastal Maine trying to buy my spent inventory? I have not heard from them. I'm not sure that I'm big enough to make a difference in their compost system, but what Ruben and I are trying to figure out is, if you buy, you know, for farms that are buying in slings of expensive compost, is there value to adding some spent mushroom substrate and perhaps, you know, some of my compost to, and then let that incubate, you know, for a few weeks if you're buying in your sling of compost, you know, early or midwinter. I know some of the companies advertise and get folks to take it in the fall when they can deliver for cheaper. You know, that's something I would like to test out, is take a good compost that people already use, see if we can make it even better by inoculating it with some spent mushroom substrate, which will then work on, you know, any carbon source that's still in there, decomposing that, and then we can introduce the some worms and some of the microbial diversity and see if we could bring it to life even more than what it already is.
Yeah, especially this is especially true for not to talk down about municipal composting, but municipal composting, as we know, it's not done with the best intentions. Oh, actually, no, sorry, it's made with the best intentions. However, it's just not done properly. Yeah, the intention is to actually remove all this waste from areas that it's necessary, but the end product is not the best. And so this is a perfect example, is to actually, you know, use municipal compost and enhance it this way.
Right.
Totally.
For a lot of people, you know, it's cheap garden center compost, right? 40 bucks a yard or something like that, just made with very basic ingredients. So could you, if that's what you are using, could this effort improve it with a little bit of time?
Yeah, that's interesting.
Another kind of like silly question, but can the substrate compost on its own? Like, what happens in the next phase of substrate? I got something this year from one of the mushroom farms down the street, and I thought it was like composted and ready to go onto the soil. It was like really stinky and like fermented, and I don't know what it was. So I'm wondering if maybe.
So what comes out of our grow rooms is pretty clean. So in the mushroom growing process, you start with sawdust and soybean hulls. That's pasteurized and then inoculated with the mushroom you're trying to grow. So what comes out of the grow room only has sawdust, soybean hulls, and the mycelium of one kind of mushroom. It does have airborne, any bacteria that might be airborne That's where we get the trichoderma, and there are a few others that can show up in the grow rooms, but that's all you're getting. So I think adding, even a small amount of soil, leaves, grass clippings, something to introduce some diversity is necessary to get it going.
Makes sense. Do you have any other questions from the audience, participants?
If nobody has any questions, I do want to address a comment that was made earlier about how nematodes travel. So in Japan, they actually did a recent study came out where they were observing nematodes, and apparently they are actually partnering with the electromagnetic currents of bees and other insects, and that electrostatic is actually how they're actually traveling. So they actually saw these nematodes actually jump from a plate into, they obviously didn't have a bee in there, but they actually recreated what the bee would do and just zapped it right up. So our flying insects they're traveling by electrostatic currents. Probably not that many people care, but
We care, Rubén. We
Well,
care.
Answer that question of how'd that stuff get in there anyway, right?
well, yeah, no, exactly. So, a lot of times we think about these things like, well, how did they actually get into this pile? And this goes back to, again, your environment. Your environment plays a huge role in how we do these things. Not every environment is going to be the same. There was one environment where I went back and I saw slugs the sizes I've never seen before. And they are bringing their own microbiome as well. So that single thing can actually make a big difference.
Yeah, if anybody knows where maggots come from and stuff, we can move that to Hoover and have a conversation in Hoover about it. So where does it come from? I think I like that thread. All right. Well, we are coming up on time, folks. Thank you so much for attending. Thank you, Rubén. Thank you, Liz. I had so much fun learning from you both. In the chat, I've placed a evaluation for this workshop and the auction link as well. If you haven't had the chance to look at it, please. There's really, really great stuff in there. So with that, we hope we see you at more workshops and on Saturday.
Thanks, everyone.
Thank you all.